Lesson 117, significant digits. So what do they mean by significant digits? Well, when we measure things or we count items, we can have an exact number or we can get very close. But the more precise you are with your numbers, the better it is. And sometimes we can't be as precise with our answer because we don't know for sure what it is. So when you think about it on a ruler, usually the ruler has on the centimeter side goes to millimeters. And so you go to the nearest tenth, but we can't go to the nearest hundredth or thousandth place. So we can only go with what we know for sure. And so when we're looking at numbers and significant digits, we're only going with what we know for sure, the precise amount. And so there are some rules that we're going to be following for counting significant digits. And these 6 rules you can see on the screen right now. First one is count all non-zero digits. So the number 2.54 has 3 significant digits. We got 1, 2, and 3. Those are all non-zero digits. So all of them need to be counted. The second rule, count zeros between non-zero digits. So the number 10.7 has 3 significant digits. The 0 is between 2 non-zero digits, so we would need to include that. The third rule, count trailing zeros in a decimal number. So the decimal 1.20 has 3 significant digits because the 0 is after a digit that's non-zero and it's after the decimal point, so we need to count that. Rule 4, do not count zeros if there is not a non-zero digit to the left. So the number 0.023 only has 2 significant digits because if you look at these first 2 zeros, there's not a non-zero digit before it. Therefore, we do not count them. So the only digits we would count are 2 and 3. Rule number 5, trailing zeros of whole numbers are ambiguous. The number of significant digits in 1,200 might be 2, 3, or 4. Expressing a number in scientific notation removes the ambiguity. The number 1.20 times 10 to the third has 3 significant digits. As you can see them all listed here. The exact number have an unlimited number of significant figures, so we do not count any digits when dealing with exact numbers. So exact numbers include counts and exact conversion rates like 3 feet per yard and 2.54 centimeters per inch. So if we have an exact number, we could just say exact or unlimited number. So let's take a look at an example. It says state the number of significant digits in letters A to D. So letter A, the diameter of a quarter is about 2.5 centimeters. This would have 2 significant digits, 2 and 5. Letter B, a ruler is about 30.5 centimeters long. Since my 0 is between 2 non-digit zeros, I can count the 0. So we got 1, 2, 3. So 3 significant digits. Letter C, the Earth's average distance from the sun is about 9.3 times 10 to the 7th. I have 2 digits here, so this would make that 2 significant digits. And letter D, a mile is 5,280 feet. Since this is a conversion and we have an exact number in our conversion, we would call this unlimited or exact. And I'll just use the word exact. Next one, write this number of significant digits in letters A to D on the other side. So we got 10.68 seconds. That has 1, 2, 3, 4 significant digits. Again, we count the 0 because it's in between 2 non-zero digits. Letter B, 0.063 liters. This one would have only two significant digits, 6 and 3. The reason because the two zeros at the beginning, there's not a significant digit to the left of them, so we do not count them. Letter C, 4.20 kilograms has 3 significant digits. 1, 2, 3. The 0 is counted because it's to the left, or the non-zero digit is to the left. Left of the 0, it's also a trailing 0 after a decimal. Letter D, we got 1.609 times 10 to the third. This would have 4 significant digits. 1, 2, 3, 4. Again, the 0 is counted because you have non-zero digits in between on each end of the 0. Next, a product or quotient of two measurements may only have as many significant digits as the measurement with the least number of significant digits. So in other words, if you're multiplying or dividing two numbers, whatever number has the least amount of significant digits, that's as many significant digits you can have in your answer. So it says if the segment 8.9 centimeters long is divided into 4 equal segments, what would be the length of each segment? So I would need to take my 8.9, divide that by 4, I'll put my decimal point up. 4 goes into 8 2 times, 4 times 2 is 8, subtract, I get 9. 4 goes into 9 2 times, 2 times 4 is 8, subtract, I get 1. I can go down, there's technically zeros here, I can bring this down. 4 goes into 10, that again will be 2 times 8, and it's just going to be repeating with 2. So we got 2, 0, I can bring it down, we brought the other 0 down, 4 goes into 20, actually 5 times, and that's where you're 20. So we have 2.225. So now if we look at our two numbers, 4 and 8.9. 4 is an exact amount, so that's unlimited. So the number of significant digits does not count towards that one, since that's infinite amount. 8.9 has only 2 significant digits. That is less than the number of significant digits number 4 has. So I can only have 2 significant digits. So I would have to round this answer to 2 significant digits, which would make that 2.2. Next one, solve and express each answer with the correct number of significant digits. So I have 3.6 times 4.2. So 3.6 times 4.2. They both have 2 significant digits, so I can only have 2 significant digits in my answer. So let's just solve this first. So 6 times 2 is 12. 2 times 3 is 6, plus 1 is 7. 4 times 6 is 24. 4 times 3 is 12, plus 2 is 14. I have two digits in my problem, so I need 2 in my answer. So I have 15.12. But I can only have 2 significant digits here. So I have to round 15.12 to the nearest ones place, so it would be 15, because I can only have 2 digits, significant digits, so that would make it 15. Next one, 164 meters divided by 1.2. The least significant number each of the numbers have is 2 here, so I can only have 2 significant digits in my answer. Remember, I can't divide by a decimal, so I'm going to move the decimal place 1 to the right. So now I have 164 divided by 12. 12 goes into 16 one time. 1 times 12 is 12. You have 4. 12 goes into 44. 3 times. 3 times 12 is 36. Subtract and you get 8. Bring down to 0. 12 goes in 80. That would go in, that'd be 60. 6 times, that would give us 72. There's actually a decimal point here. So we can only go 2 significant digits, so I'm going to stop right here. Since this is a 6, that tells me to round the 3 up to 4, so this would be about 14. And our last slide. A sum or difference may show no more decimal places than the measurement with the fewest number of decimal places. So the same thing that we had for multiplication and division, we do with addition and subtraction. So it says the test tube contains 6.24 milliliters of liquid before it was heated and 4.6 milliliters after it was heated. How many milliliters of liquid evaporated when the test tube was heated? So for this one, I would have to subtract. So I got my 6.24 minus my 4.6. This is a 0 here. So when I subtract, get a 4. Need to borrow. 12 minus 6 is 6. 5 minus 4 is 1. But the one number that has the least amount, I'm going to not put that 0 there because there's not a 0 there. Just know when you subtract, it is there. But when you count the significant digits, it's not there because they only give us 4.6. So this one has 2 significant digits. This one has 3. I always go with the one that has the fewest number of decimal places. So there's only 1 decimal place here. So I don't need to use this part. So my answer would be 1.6 milliliters. Next one, solve and express each answer with the correct number of significant digits. So I got 1.24 plus 6.4 plus 5.1. 1.24, 6.4, and 5.1. Add them together, I get a 4 here. 6, 7. 7 plus 5 is 12. Here again, the fewest number of decimal places. Fewest one has 1 decimal place, so I can only go to 1 decimal place. So this would be 12.7. This would be grams. And the last one, 0.249 liters minus 0.12 liters. So 0.249 minus 0.12. Got 9, you got 2, you got 1, decimal point 0. But the fewest decimal places is 2, so I can only go to 2 places. So my answer for this one, rounded to the next digit here, would be 0.13. This would be liters. So that's our lesson today on significant digits.